China has taken this to another level with its social credit system, where AI monitors citizens through millions of surveillance cameras with facial recognition. The system scores people based on their behavior, affecting their ability to get loans, jobs, or even buy train tickets. But it's not just China. AI-powered surveillance is being used worldwide. In the UK, police have tested real-time AI facial recognition, scanning people in crowds without their consent. In the US, AI is being used for predictive policing, analyzing crime data to forecast where crimes might occur next, a system that has been criticized for reinforcing racial and economic biases. The scary part? AI surveillance is becoming more advanced. Some systems can now detect micro-expressions to analyze. A 2024 study found that AI-generated images and videos are now more convincing than real ones, making it nearly impossible for the average person to detect fakes. If seeing isn't believing anymore, how do we protect the truth? Number 1, super intelligent AI. This is the AI nightmare that even the world's top scientists and tech CEOs are warning about. We're not talking about chatbots or self-driving cars. We're talking about AI that surpasses human intelligence and starts making decisions beyond our control. Elon Musk, OpenAI's CEO Sam Altman, and thousands of AI researchers have signed warnings about the risks of uncontrolled AI development. Jeffrey Hinton, known as the godfather of AI, resigned from
the conclusion of a detailed, step-by-step forecast for what could happen in our world by the year 2028. This is the story of the single most important technology ever created, a new form of mind that could solve humanity's greatest problems: disease, poverty, even death itself. But it's also the story of a terrifying possibility that the same creation, born from our own ambition, could decide that the greatest problem of all is us. Now, you might think this is just alarmism, but over the next few minutes, I am going to show you the 4 critical steps that insiders believe could lead us from where we are today to. It's the logical endpoint of a race that is already well underway, and it's happening faster than most people realize. Right now, the United States is waging a full-scale economic war to slow down China's access to the world's most advanced AI chips, with strict export controls on companies like NVIDIA. In response, China is pouring billions into a national-level effort to develop its own semiconductor industry, explicitly framing it as a matter of survival. This isn't just business, it's a 21st century arms race, fought with silicon and algorithms instead of steel and gunpowder. And in that kind of race, national security.
Just below, the activation functions are defined. We're using TNH for the hidden layer and sigmoid for the output layer. In the loop function, we read the analog value and normalize it to a range between 0 and 1. Then we calculate the weighted sums for the hidden layer using the weights and biases, and pass the result through the activation function. We do the same for the output neurons. Finally, we scale their values to a range of 0 to 255 and send them to the 3 PWM pins to control the LEDs.
Oof, that was tough. Now I need a quick break before I try this on a real Arduino. And while we are pausing, it's a perfect time to chat about my sponsor, PCBWay.
All we need to do is to install the AIFS Arduino library using the library manager, then include the header file I mentioned earlier, call the model initialization function without parameters in the sketch setup, and then use the inference function inside the loop. This function takes 2 parameters, the address of the normalized analog input value and a reference to the output values array. Its values then just need to be written to the LEDs in a for loop, and just like that, the neural network is up and running on an Arduino. It makes perfect sense to use this network for a VU meter. For that, the input values in the training data should be arranged exponentially so that each